Hello, my name is Anthony Model and I'm in Chem 117, and I'm about to illustrate the concept of phase diagrams with H2O and CO2. But before we start, remember, safety is groovy. First thing you're going to want to remember is you need to be in a well-ventilated area. Luckily, this area is well-ventilated. Second thing you're going to want to need is you're going to need a lab coat. All right, now we're ready to begin the experiment. Materials. What I have in front of me is solid CO2 and solid H2O and liquid H2O. Now, at room temperature and atmospheric pressure, like it is in this room, the solid CO2 sublimes. It goes directly from solid phase to gas phase as the temperature increases. Now, H2O on the other hand melts according to their phase diagram. So now, what I'm going to do is I'm going to create liquid CO2 by increasing the pressure as the temperature increases. Next thing we will do is we will increase the pressure by closing off the apparatus with a pair of pliers for safety, of course, and then we will insert the apparatus into the water to illustrate the pressure increasing and the temperature increase.
By closing off the apparatus, we prevent the CO2 gas from escaping. This increases the number of moles of gas, and we know that as the number of moles of gas increases, so does the pressure. Placing it in water heats the CO2 up faster. Once the pressure increases roughly past 5 atmosphere, the CO2 is able to form liquid, and the CO2 is able to reach its triple point since the liquid, solid, and gas are all coexisting at once. In order to prevent the apparatus from exploding, I then release the pressure. Now I'm going to illustrate this with another trial I did with a phase diagram. So as you can see, this is the phase diagram for CO2. And at atmospheric pressure, as you can see, cannot exist as a liquid since it has to at least be 5.11, roughly there, 5.11 atmospheres to exist as a liquid. So by increasing the pressure, we are allowing pressure to increase, and the temperature is increasing because it's exposed to the water, which is at like room temperature, which is somewhere over here. And as you can see, presence of a liquid, we know it's roughly at that triple point. And then we release the pressure. It releases energy through vaporization, and the pressure decreases immediately, and it re-solidifies. We can contrast this with water, which according to its phase diagram, at the same atmosphere, it can exist as a solid, liquid, or gas just by increasing the temperature. It would take a ridiculously low pressure to illustrate the same concept with H2O.
I hope you have a wonderful rest of your day. Thank you, and Gig Chem.